What I thought we would do next is actually talk about half a dozen or so different games that we've worked with and how we work with them and what we did and how those engagements went, so you get a feel for kind of what we do. Because I mean, we talked about a lot of the group's functions, but I think it's much better to kind of go through each game in turn. So whenever we engage, the number one goal is to make the game better. Make it visually cooler, make it more fun, make it a better game. Interestingly, the other goal is to never do any harm. And what I mean by that, and you'd be surprised, a lot of times you can go in, you can kind of try to jam something in, but you'll end up breaking 5 other things along the way. And game developers hate that, right? They have a schedule, right? They need to ship. Game development, a lot of games are, they got to get out by Christmas, all that kind of stuff. You don't want to break anything. And the other thing you don't want to actually hurt anybody else's performance or capabilities either. So when we go in and we do some features or performance optimizations, we always want to always improve things for everyone, right? Or certainly make them no worse for anyone, right? Because there's different hardware implementations have different ways to optimize for them. But whenever the developers really appreciate what we do, because what we do it may help NVIDIA and it may not hurt ATI, or it may help ATI and NVIDIA, but we'll never put something in which hurts ATI to help NVIDIA. No developer likes that. Why would they like that? Because they want to sell their game on ATI hardware too, and you want to not have a bad experience there either. So that's actually a really important tenet of the way that we engage with developers, is this do no harm thing. No one wants to add work, or you want to minimize the work you add to the game developer, right? They're running on tight budgets and schedules. And then you want to just make sure that you're doing what they want done. If you, at the end, it's their game. It's their art. It's their creation. You want to just make that better. So anyway, there's a list of games we're going to walk through. Each one has a little bit of a tale or a story to it. So we'll actually have Shu walk through the first few, and then I'll walk through the second half of those.
All right. So one of the games, and this actually, it's interesting because especially since you guys are from the APAC side of the world, we have actually a substantial investment in all of the countries in APAC. We have people in China, of course, in Shanghai and in Beijing. We have people in Seoul. We have people in Tokyo. And all of these guys cover pretty much all of the Pacific Rim. And so we work with a lot of key developers in, for example, China. And one of them has done this game called Star Tales, which is not your typical shooter or a game where you're blowing up stuff, but it's actually a very popular game where you're supposed to come on. You have this virtual avatar, and you have sort of this dancing thing, and you can dress up your avatar in different clothing and put them through their moves and so on. So obviously it's a game targeted for a very specific audience, not your typical gamer. So this is based on Unreal Engine 3, which is a very popular engine, as you know. And it's a DX9 based engine primarily, and it does not support anti-aliasing because of certain formats that are hard to do anti-aliasing on in DX9. So we decided, well, we want the game to look better, and why don't we add anti-aliasing support to this game? So we went ahead and started working on that, and we added the effect generically without regard for which GPU. The only requirement was that it be DX9. And it turns out that we discovered that because we were doing this sort of testing across different configurations, we discovered that it actually did not work at all on AMD GPUs. And this is because at the time, AMD drivers did not support anti-aliasing on a specific format, G16 or R16 floating point format. And because Unreal Engine uses that fairly extensively, it was, caused all kinds of artifacts all over the place. So I distinctly remember this where my guys in Shanghai wrote me a frantic email saying, the developers don't have AMD hardware to test with, so we cannot really fix this issue on site. Can we go ahead and buy a GPU, AMD GPU for them? And I said, sure, why not? So we actually purchased an AMD GPU to give to the developer for their testing. And then my guys worked there pretty much around the clock for 2 days because the game was going gold. It was going to go online, live, to get the workaround for AMD, which was going and working through literally all the, I don't know if anybody has looked at Unreal Engine 3, but it's a pretty complex engine. So you have to go and figure out all kinds of stuff. Okay, this surface is used here, and maybe we do this workaround here, and so on. It was a lot of work, and it was pretty substantial amount just to fix anti-aliasing for A and B. We could have just gone and said, not bother with that part, but we went ahead and did that because we wanted to make sure that the developer got the benefit for all of their